Hello everyone, I am Pavitra Devi, working as Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science in Dr. S.N.S. Rajashmi College of Arts and Science. Now I am going to take the class about Computer System Architecture. Computer System Architecture is nothing but is basically a machine that simplifies the complicated task. It should maximum performance and reduce the cost as well as power consumption. The different components in the computer architecture are input unit, output unit, storage unit, arithmetic and logical unit, control unit, etc. The diagram shows the flow of data between these units the followings. The input data travels from input unit to ALU, arithmetic logical units. Similarly, the computer data travels from ALU to output unit. The data constantly move from storage unit to ALU and back again. This is because stored data is computed on before being stored again. Control unit control all the other units as well as their data. Next one, computer units. Input unit provides data to computer system from outside. So basically it links the external environment with the computer. It takes data from the input device, convert it into the machine language. Then it load into the computer system. Keyboard, mouse, etc. are the most commonly used input devices. Output unit. The output unit provides the result of computer process to the user. That is the link the computer within the internal and external environment. Most output of the data is the form of audio or video. The different output devices are monitor, printer, speaker, headphones, etc. Next one, storage unit. Storage unit contains many computers components that are used to store data. It is traditionally divided into primary storage, secondary storage. Primary storage is also known as main memory and is memory directly accessible by the CPU. Secondary or external storage is not directly accessible by the CPU. The data from the secondary storage need to be brought into the primary storage before the CPU can use it. Secondary storage contains large amount of data permanently. Arithmetic logical unit. The arithmetic logical unit calculation related to the computer system are performed by the arithmetical logical unit. It can perform operations like addition, subtraction, multiplication, division, etc. The control unit. Control unit transfers the data from storage unit to arithmetic logical unit when calculation need to be performed. The arithmetical logical unit are controlled together from the central processing units. Next one, control units. This unit control all other units of the computer system and also known as central nervous system. It transfers the data throughout the computer as required, including from the storage unit to central processing unit and vice versa. The control unit is also dedicate how the memory input device, output device, arithmetical logical unit device, etc. Next one, single processor system. One main CPU with manage the computer, run user apps. Other specialized process, disk controller, GPUs, etc. do not run user apps. Almost all single processor systems have the other special purpose processor as well as. They may come in the form of device-specific processors such as disk, keyboard, and graphics controller or mainframes. They may come in one form of more general-purpose processors such as input-output processor that move data rapidly among the components of the system. All of these systems, special-purpose processors run a limited instruction set and do not run user process. Next one, multiprocessor system. It is also known as parallel system or multi-core system. Such as system have two or more processors in close communication, sharing the computer bus and sometimes the clock, memory, peripheral devices. Advantages: increased throughput, faster execution but not 100% linear speedup. Economy of scale, peripheral disk memory shared among the process. Increased readability, failure of the CPU slows the system, does not crush it. Redundant processing provides system of check and balancing, example NASA. Next one, clustered system. Another type of multiprocessor system is a cluster system. Cluster system different from the Multiprocessor clustering is usually used to provide high availability services. That is, service will continue even if one or more systems in the cluster fail. Clustering can be structured asymmetrically or symmetrically. In asymmetrically clustering, one machine is in hot standby mode while the other running the applications. Symmetric clustering, two or more hosts are running applications and are monitoring each other. This structure is absolutely more efficient as it uses of the all available hardware. Independent system with a shared common storage and connected by the high-speed LAN working together. Special consideration for the access to shared storage or required distributed log management or as our collaboration protocols. Thanks for the giving this opportunity. Thank you.